This project is for education purposes only. The authors take no responsibility or liability for how you choose to use any of the tools or source code or any files provided. The authors and anyone affiliated with this project will not be liable for any losses and/or damages in connection with use of any files provided with this project. By using this project or any files included, you understand that you are agreeing to use it at your own risk. Once again, this project and all files included are for education and/or research purposes only. This project is only intended to be used on your own pen testing labs, or with explicit consent from the owner of the property being tested. For this project, a remote access Trojan was created that will establish administrative control over any machine it compromises. The remote access Trojan should be able to accomplish the following: monitoring user behavior through keylogger capabilities. That is, capturing keystrokes and screenshots. Along with that, the remote access Trojan should be able to activate a system's webcam and record video. The name given to the Trojan is ConTroll. Along with the base requirements of this project, more bonus capabilities were added. These added capabilities will be demonstrated in this presentation. Alright, let's begin. First, the hacker starts by building a server, to which the Trojan will connect to receive commands. This server is what the hacker uses to control the victim's machine through the Trojan. For ease of implementation, the hacker decides to only infect a single network and one single victim at a time, using the TCP implementation of sockets programming in Python. This, however, means that the hacker must be on the same network as the victim and can only infect one victim at a time. This limitation is easy to overcome. All the hacker would have to do is just switch from the TCP protocol to the HTTP protocol, as well as adding threads to handle multiple victims. But for now, the hacker wishes to start small. Notice how the hacker hard-coded his IP address and the port he wants the server to listen on. The Trojan will need to have similar values here for a successful connection. Switching over to the Trojan client, you'll realize that at first glance, it is very similar to the server implementation, where you can see the hacker's IP address as well as the port the server is listening on. The Trojan client, however, contains a lot more functions than the server. These functions are activated remotely on command of the server. Some functions of the Trojan client includes exfiltrating passwords stored in Chrome, activating webcam and microphone, key logging, screen capturing, opening CD drive, and more. Before the hacker deploys the remote Trojan, he makes sure all is well with the code, to guarantee maximum results. After double-checking his code and seeing that all is well, the hacker thinks of a way to spread the Trojan. After penciling his options, the hacker decides to spread the Trojan through a cloned version of the popular and addictive Flappy Bird game. Because of its popularity and addictive nature, the hacker knew he could infect potential victims easily through this method. There is, however, a problem with the hacker's plan. If he attaches the Trojan to the game, the Trojan would disconnect from the server as soon as the victim closes the game. So what the hacker did was create a module inside the game that will go to the hacker's LAN server and download and run the Trojan as a separate process from the game. This allowed the server to be in full contact with the Trojan client even after the victim closes the game. Now that the server, Trojan client, and the Flappy Bird game is ready, there is one thing left for the hacker to do before deploying, and that is creating exe binaries for the game and the Trojan client. Now that the hacker has the exe binaries for the Flappy Bird game and the Trojan client, he sets up a LAN server to host the Trojan client. This server is where the Flappy Bird game will download the Trojan client. After setting up the LAN server with the Trojan client, the hacker looks for his victim. After spotting a potential victim, the hacker proceeds to social engineering the victim into downloading and playing the cloned version of the Flappy Bird game. Now that the target has been convinced to download and play the game, the hacker returns to his computer, starts the server and waits for a connection from the Trojan client. When the victim downloads and opens the game asks for administrative rights to open. This means that when the Trojan client is downloaded and ran under the game's process as a separate process, it also inherits administrative rights, with the victim allowing the game to run as administrator. Watch how as the victim begins to play the game, the hacker's server receives a connection from the Trojan client. This indicates that the Trojan client was successfully downloaded and executed from the hacker's remote LAN server. Upon connection, you can see that the hacker is provided with the victim's local IP address, a session number and a shell prompt. This shell prompt is a copy of the victim's command prompt console, which means that the hacker can execute any command prompt command remotely on the victim's computer. An example of a command prompt command is, "Who am I?" This command returns the current domain and user name. Watch how as the hacker executes this command, the victim's domain and username is displayed. Just to show you how much hold the hacker already has over the victim's computer, here's a list of commands the hacker can execute right off the bat without even having to program them into the Trojan client. Now that you've seen the commands the hacker can execute without having to code, let's take a look at the list of commands the hacker has coded into the Trojan client and demonstrate the execution of each. Let's start with the about command. This command returns basic and general information about the victim's machine. Activate webcam. This command activates the victim's webcam and displays a live stream of the victim. Activate mic. This command activates the victim's microphone for a set period of time. The value placed after the command is the length of the recording in seconds. This recording is stored in temp data on the victim's machine and sent to the hacker when the get recording command is sent from the server. Get recording. This command sends the audio recorded from the victim's microphone to the hacker's machine through the server. After sending the recording to the hacker, the audio file is deleted from the victim's temp data. Start logger. This command activates the keylogging capabilities in the Trojan client. Once the logger starts, it creates a log file with all the keys typed by the victim and stores that file locally in the victim's temp data. Stop logger. This command tells the Trojan client to disable the keylogger. After this command is executed, the Trojan stops logging the keys typed by the victim. Get log file. This command retrieves the log file created by the keylogger from the victim's temp data. When the file transfer completes, the log file is removed from the victim's temp data. Screen cap. This command returns a screen capture image of the victim's computer screen. Chrome dump. This command returns a file to the hacker with websites the victim saved in their Chrome browser, along with their username and password in plain text. Lock screen. This command logs the victim out of their computer and locks the screen. Open drive. This command simply opens the victim's CD or DVD drive if they have one. Grab. This command exfiltrates files from the victim's computer. The value sent after the grab command is the file the hacker wishes to copy over to his machine. Speak. This command utilizes the built-in speech synthesizer on the victim's computer.
I'm inside your computer.
Whatever is sent after the double dashes is spoken by the synthesizer on the victim's machine. The final command is troll. This command creates a dialog pop-up on the victim's computer and has 4 parts to it that are separated by double dashes. The first part of this command is the text you want to be displayed in the pop-up dialog. In this example, the hacker chose to use "Serious Threat Detected" as the text to display in the pop-up. The second part of the command is the button plus icon code the hacker wants on the dialog pop-up. The hacker here uses 0 for the button code and 16 for the icon code. The 0 represents a normal OK button, and 16 represents the critical message icon. For more information on the different button and icon codes, you can type "me", and the codes will be displayed. The third command is the title of the dialog pop-up box. Here the hacker used "warning" as the pop-up title. The final part of this command takes an integer value, which represents the number of times the pop-up should show up on the victim's computer. For persistence, the Trojan client has a disabled feature built inside it. This feature, when enabled, will write the Trojan to the victim's startup registry, making the Trojan able to run and connect to the server, even after the victim restarts their computer. The way the client was built will allow it to connect to the server once it is available. So even if the victim leaves the infected network, once they return, their system will remain compromised. Once the server's IP address on the infected network remains static, there is no escaping the controller.